Good afternoon and welcome to CDT's Technology and Tips webcast series. Today we're going to be covering a few of the advanced assembly features in Creo Parametric 1.0. Thank you for joining us. For those of you that are new to CDT webcast series, you can listen to the demo over your computer, which you probably already are. However, if you prefer, if you're having some audio issues, you can listen in on the telephone by selecting the radio button located next to the word telephone in the GoToWebinar window. Just note that your audio will be muted during the presentation. We will save the questions until the end. However, feel free at any time to type your questions into the question box, and our moderator, Rosalinda, will relay them on to me at the end of the presentation. The webcast will be recorded and uploaded to our YouTube channel. After we're finished, you'll be able to find a lot of our past webcasts there as well. So my name is Brad Heuiser. I'm the local applications engineer for CDT in St. Louis, Missouri. For those of you who know all about us, you've already heard this many times, but for those of you that are new, maybe this is your first webcast, you aren't familiar with what CDT is or what a value-added reseller is, we like to think of it as, we sell and service all of the PTC products, whether that's Windchill, Creo, MathCAD, ArborText. But the best analogy that I've heard for our relationship with PTC is that PTC is like Ford Motor Company, and we're like your local Ford dealership. They make the product, we help sell it, we help service it. When you have issues, you can come to us, and if we can handle it, we will. Otherwise, we'll forward you back on to PTC for the bigger stuff. So we have also an excellent staff of experienced migration and integration services personnel. We handle, whether that's Windchill or Pro Engineer, Creo, Parametric. We do support the migration integration services for those. What really sets CDT apart, though, is our dedication to support. Our group of applications engineers devote a lot of our free time to helping our customers out. When we're not teaching classes or doing product demonstrations, we're here to help you. As a matter of fact, I'm technically on my lunch break right now. I'm teaching an intro to Creo Parametric 1.0 class. After we get off this, I'll jump right back in and start teaching again. Hopefully the students will be a little lenient with me and let me chow down on my lunch before we go right back into that. It's important to note that we do have 3 PTC certified training centers, one in Kansas City, one in Arlington, Texas, which is basically Dallas, and of course my personal favorite right here where I'm sitting, St. Louis, Missouri. CDT is also unique in that we're one of the only VARs, if not the only one, that will run classes with only 1 to 2 students. The class I'm actually teaching this week has only 1 student. I actually kind of prefer it that way. It's kind of a one-on-one mentoring type thing. You see a class on our schedule. You don't have to worry about if you're the only student signed up about the class being canceled. We do guarantee our classes. If you want to go to our website and check out what training classes we do offer, you can register for those classes straight through there, or you can go through PTC. Our classes are listed on PTC's website as well. That website address is cdtplm.com/training. So if you're looking at our schedule and you see what we were offering and there's maybe something that's a little beyond the scope of what we're doing or something that maybe we've offered in the past that isn't currently on the schedule, please let us know. We do currently change the schedule around to accommodate anything that people are looking for. And I'm new enough to CDT that I'm still gaining my certifications for a lot of classes. So in a couple of cases I've actually gone out and gotten a certification on something, some material I was already familiar with, but I went out and got certified to teach it because there was a specific customer that was looking for that specific class. I'm sure most of you have heard by now that almost a month ago CDT was acquired by Barry-Wehmiller here locally in St. Louis. I've been getting a few questions about it, and I've actually heard a couple of nasty rumors that we were bought out to keep us from going out of business, but exactly the opposite of this is what's actually true there. CDT has been doing so well, in fact, that they began expanding their business about 6 months ago. That's why they hired me and the local sales guy here in St. Louis, JB, because they had enough business that was keeping the guys out west and in the southwest a little bit too busy to cover St. Louis anymore. So once I got hired on because of that, about that same time, Barry-Wehmiller we caught their eye, and they were looking at what we were doing, and they thought we would be a good potential acquisition. So they started doing the talks with TJ, and turns out we have some areas where we can overlap quite nicely. Now we are able to give them some expertise in the areas that we've proven to be good at, and they're able to offer some unique services through us that potentially were not available before to a lot of our customers. And we're still defining a lot of that. There'll be a lot more details as further into that as we go. But one thing I can tell you is that the move has turned out to be really good for both of us, both Barry-Wehmiller and as the CDT employees. And I'm very happy to now be a Barry-Wehmiller employee. So today on the agenda, we're going to talk about the advanced assembly within Creo Parametric. I'll start out by giving an overview of top-down design. Then I will talk about skeletons, envelopes, and simplified representations. After that, I'll show a demo of some of the features we've been talking about, and I'll follow up with a Q&A session. At that time, if you guys have any questions that you've entered in, you can type them in at any time, and we'll get to those at the end. There are also a few other things I'd like to mention if we get the time. Unfortunately, there is so much material here with the advanced assembly that I could probably easily do another one, if not two more webinars and still not cover all of the material. So this one is going to be a little more high level, show you some of the basic stuff, and then if you guys show enough of an interest in maybe some of the more advanced features, we can get into that at a later date. So before we jump in, as you guys are used to by now, we like to ask some poll questions to the audience. Rosalinda, could you please put those poll questions up now?
Sure thing. Okay, I have a couple of more. Okay, Brad, it's all yours.
All right, thank you, Rosalinda. Again, we do appreciate your participation. This is what allows us to make sure we're showing you the things that are relevant to you. You know, we don't want to consistently pitch a bunch of software to people that aren't interested in seeing what we're pitching. So we do again appreciate your participation with these polls. So let's get started with a quick discussion about top-down design. I'll go ahead and admit that I've really just been looking for an excuse to post this picture right here because I think it's pretty cool. I like seeing what people are creating out there with Creo software. So this is one of those cool assemblies that I get to come across on a regular basis. So let's start first by talking about top-down design by saying what it isn't. So what isn't top-down design? Well, bottom-up design is a good example of what top-down design isn't. So those of you that know me or have taken one of my training classes know that I grew up playing with lots of Legos and pretty mechanically minded, like that sort of thing. My love of the toys lasted into adulthood. Now I get to play with them again with my two young sons. These are actually their Legos. I took this picture last night while I was prepping for this. So Legos are a good example of the bottom-up design approach. You start small, and as you go along, you get bigger and more complicated. Many times you invest a large amount of time into a design and have to go back and backtrack. You might have to change your design a little to remove features or add things here and there to get to mesh with the rest of the big picture. I've actually worked for companies in the past that have they seem to employ this bottom-up design approach, and just like Legos, the designs seem to start out small and grow into large, super complicated designs. Many times when it wasn't used correctly, the features that are added and then redefined and removed many times in ways that just seem like they add extra work. Many times features aren't added at all. Features that make sense when you take a step back and look at the big picture. This is good if you like job security because it allows you to continue doing the same work over and over, and there's always that nice big backlog of things that need to get done. I personally didn't like it very much at all. So what is top-down design then? If it's not bottom-up design, what is it? When I first started prepping for this webinar, I couldn't really give a good answer to that question. So like everyone does, I got out on the internet and searched far and wide, And the farther I searched and the wider I searched, the more and more confused I got, because it seems everybody has their own definition of what top-down design is. I kind of simmered it down to a few different simple points that I think make sense in this situation of what PTC says top-down design is, and that top-down design approaches emphasize planning and a complete understanding of the system. Top-down design also breaks the assembly into smaller sub-assemblies to tackle each part of the system separately, and it allows many teams of designers to work on the same problem concurrently. So instead of working end to end, waiting for someone to get done with the part, you can work on something else while someone else is working on a different component of the assembly. The top-down method design eliminates many of these issues that I had to deal with at my previous employer. If I'm given a strict criteria at the beginning of my design, I know where my limits are, I know what my expectations for the final design are. Think about designing a component in the engine bay of a modern automobile. It seems most modern automobiles barely have enough room to get under the hood to even access your spark plugs. If you didn't impose constraints on all the different groups that are designing these different components, there's no way they would all be able to agree on where everything would fit and where it would go, how big it needs to be, and people would just be constantly arguing back and forth over what space they're allotted. So I'm going to steal this slide from PTC. This one explains some things pretty simply. It uses this top-down approach to define the function of each of their different design areas from the very beginning. Note how they started up here in the top right, step 1, with a conceptual design and broke it down into 6 basic sub-assemblies, as you can see right here. From those 6 basic sub-assemblies, they use a skeleton model, which we'll talk about shortly, to capture the design intent. They manage the interdependencies of the interchangeable components, which, if we have time, we'll get to that too. I like saying that. It makes me sound really smart. They communicated the design intent, again, using skeleton models down here in step 5. And in step 6, once they had their 6 concurrent design groups complete their sub-assemblies, they brought everything back together in the final assembly, saving a large amount of time by allowing everyone to work concurrently. So you're probably wondering, what was the skeleton thing we just mentioned? Well, I'm glad you asked. Skeletons are powerful tools that allow you to create the 3D layout or framework of an assembly design. They're currently used to do the following. They can create space claims for components. That is, they can show how much space I'm allotted to design a particular component. Again, if I'm designing something under the engine of an automobile, it's good to know what box I'm allowed to create things within. They create interfaces and placement references between components, which we'll briefly talk about in just a moment as well. And then they also provide motion between components. I can use them to create simple mechanisms, in this case a crank and a piston, without actually having to go in and model all of those detailed parts of the crank and the piston. Later I can come back and using that skeleton model, I can build parts off of the skeleton and keep those references. Skeletons are also given some special properties within a model. They're automatically moved to the first component in the model tree. This allows you to build the entire assembly off of the skeleton, avoiding those long, complicated loops of where things reference each other and increase regeneration times. They have no mass, and they don't show up in the final assembly bill of materials, or BOM for short. Notice they are a bright blue color, so they're nice and pretty and easy to see and distinguish from the rest of the model. And skeletons typically contain a variety of datum features and sketch features that the assembly models are based off of. So I can come back and use all of these later to create my solid geometry, or maybe this is solid geometry that already exists, and I'm just using the skeleton to simplify my assembly model to increase or decrease my regeneration time and increase my productivity. So note the following 2 diagrams. Yes, an assembly with only 4 components may not fully benefit from a skeleton, but imagine this had 400 or 4,000 or 40,000 components in it. I think it's pretty easy to see how a skeleton could decrease your regeneration times by simplifying the way components are constrained into the assembly. Creo Parametric no longer has to validate the mate between parts D and C, and also C and B, and D and B, and A, and it's a good thing that Creo's smart, because that kind of thing confuses me. On the right, you can see each component is directly mated to the skeleton, so I don't have to worry about if something changes in the mate of C to B, is that going to affect the way D mates to B and then back to A? If everything's mated directly to the skeleton, individual components can be moved and maybe even fail regeneration if someone changes them, and that's not going to break my overall assembly. Excuse me. So Creo Parametric, you can substitute large complicated components with simplified reps, envelopes, models related by family tables, or interchange assemblies. For the moment, let's talk about some envelopes. An envelope is a part created to represent a predetermined selection of components in an assembly. The envelope uses simple geometry to reduce memory usage and looks similar to the components it represents. They are only simplified representations of design models. They do not appear in the assembly bill of materials, and they do not appear in the assembly unless they are substituted into the simplified representation. So here's a good example from a training class on advanced assembly. If you look at the one on the left, that's the original camera model. It contains all of the details down to the individual resistors and capacitors on the printed circuit board. Is this something that I need to show every time I use the model? Probably not. I created an envelope part here on the right. When I'm testing how the camera mates to a mounting stand or showing how it mates to another assembly, I don't care the least bit about the internal workings of the camera or the location of each individual component. Do you care about how the circuits are situated within the cell phone in your pocket right now? No, probably not. All you care about is that it's thin enough to fit in your pocket, and as long as it makes and receives phone calls, you're still happy. Likewise, I can ignore all the details inside the camera and turn a 100-component assembly, in this case, into basically a single block part, and ignore all of the inner workings and focus specifically on the function of the part. So on that note, let's say, again, this lawnmower manufacturer we're going to show in just a minute that I've got a lawnmower with 10 minutes of processing information before I can even start working. Take a look at these two graphs. On the left here, in this case, by using two different types of simplified reps, the geometry rep and the graphics rep, I can cut my retrieval time by 50% and 75% in the case of the graphics rep. I know what you're thinking, that has to come at the cost of something else, right? Well, yeah, absolutely, but I think you'll see that the trade-off is well worth it in the long run. When opening a large assembly, I can choose to open a simplified rep of the assembly. Instead of bringing in all of those details to the master rep, I can choose to create new reps that only show a portion of the data. I can even choose to make a rep that excludes all of the internal components of an assembly and only shows the external components. Very similar to the envelope feature that we just were talking about. For now, let's focus on the graphics rep. What am I giving up to cut the regeneration time down so much? I'm just reducing the level of geometry detail that Creo will generate and show. I don't need to see all of that in the large assembly anyway. Do I need to generate the front left tire so that it's got all of the detail in the master rep when I'm showing a graphics rep? No, probably not. Do I need to be able to read the writing on the tire sidewall when I'm viewing it from a general assembly view? No, probably not. I'm happy giving it simple geometry and speeding up my assembly regeneration. From the angle I'm likely to view the large assembly, I probably won't even be able to see 75% of the components in the assembly anyway. So why would I want to make Pro Engineer go in and generate all of the small, minute details of every single component? So let's go look at what I'm talking about in Creo Parametric. A little quick note: this is the view XMark Laser Z lasers. I'm not sure how that's pronounced. Kind enough to allow us to use their models in training demos and webcasts and that sort of thing. Note that this view of the lawnmower was generated in the advanced rendering extension. The first time I saw it, I was convinced it was just a photograph, so I started looking at it a little bit closer. We will be doing another webinar soon covering the advanced rendering extension. If you're interested in that, if you're interested in making your models look like realistic photographs, then that might be something you might want to check out when we do that. So I've got my Creo demonstration I'm going to toggle over to here. So I'm going to quickly go in here. And the advanced assembly demo can be a little picky with some of the mouse clicks, so if I don't hit it right the first time, please give me a little bit of patience, because there are a lot of components in here, and sometimes the regeneration times are quite large. So I have preloaded some of the models in here just for demonstration purposes. I'm going to go to my laserz.assembly, and I'm going to open a representation. Instead of clicking open, I'm going to open a representation. In this case, I'm going to pick the laserz representation, and I'm going to click my preview window over here. This is really handy for when you want to make sure that you're not opening the actual. If I pick the master rep and see the preview over here, it's going to be the actual every single component. You can see there's a lot of extra parts in there, clearance, skeletons, and that sort of thing. But in this case, I'm just going to use the laserz, and the preview allows me to make sure I've got the right one open. You know, when it does take potentially 10 minutes to open a representation, of something, if you open the wrong one, then you're sitting there twiddling your thumbs for the next 10 minutes waiting for it to regenerate before you can close it. So in this case, I'm going to open the Laser Z, click OK, and it pops up pretty quickly because this is a kind of a graphics rep. If you notice over here on the left, I've got a couple different views that are stated here that allow me to also show some representations. Drag this just a little bit to show that this is the graphics rep, as you can see. I can zoom in on components, and it's just a basic extrusion. There's not really a lot of detail there on that tire. I'm going to go ahead and go all the way down and select that tire. Let's say I did need to do some work on this tire, though. I can come in, and I'll scroll this over so you can see. I'm going to activate that specific tire, and if I did it right, it will show me right here that it will change it to a master rep. My mouse clicks must not have been perfectly correct. It's not showing, you can see everything's still showing up as a graphics rep, but that would allow me to come in and actually work on this within the overall graphics rep. And when I open a specific part, it's the tire, they've taken a few graphic shortcuts. It's not generated in quite as high a detail as as the final model would be, but it still looks pretty good because it's a graphics rep. The surfaces should all look pretty realistic and update properly. But when I go in and edit it, it'll change it. It'll change that specific component to a master rep, and that'll allow me to actually go in and change that geometry, and it's got all of the parametric material associated with it as well. You won't notice this from this view, but a lot of the internal components on this are hidden. That allowed me to pull this up in just a few seconds as opposed to minutes. Literally, the first time I opened this assembly, the entire assembly, it did take about 5 or 6 minutes to fully regenerate everything before this assembly would open. So in this case, I'm going to go back and reactivate my overall assembly, Control A, and that will take that. For whatever reason, it's not displaying. It did change it to a master rep, but I've behind that other column as well.
Welcome to GoToWebinar, Web Events Made Easy.
I'm not going to waste your time and continue going along with it the way it was before. So let's take a look at one of the skeletons that's used to create this part. So if you notice here at the very top, like I said, there's a skeleton up here at the very beginning that's going to show, everything is going to be mated to this skeleton. If I collapse all these guys down, notice I've got probably about a dozen different sub-assemblies here. These are all sections. If I click each one individually, it'll take a second. That's the frame. This looks like it's the hydraulic section. If I expand my title out here, I've got my parking brake subassembly, I've got my fuel subassembly, I've got my seat subassembly, all my motion controls, some of my other motion control parts, my electrical system, the deck lift system, and the engine, and the actual mower deck. So you can see these are probably every single one of these components. In this case, you can say they've got numbers, and I'm missing some because these are different interchangeable parts, but there's 21 sub-assemblies that are able to be inserted into here, where you can have 21 different teams of people or 21 design engineers working concurrently. While one person's working on the mower deck, another person can be back here working on the fuel system. And then another person can be back here routing the hydraulic lines. Well, you're probably wondering, well, how in the world do they know exactly where all of those are? How do all these mate in here together? Well, I've got my skeleton. We're going to open the skeleton. And in this case, open the master rep of that skeleton. You can notice it's got some basic placeholders. This one is specifically for measuring the deck relation to the wheels and the motion. It is a motion skeleton. It'll simulate the motion of the deck raising up and lowering down. So let me toggle over here. Excuse me. Allergy season's coming in full swing here in St. Louis. Hopefully the rest of you guys across the country are not getting impacted with that as badly as we are. So I open my skeleton, and I'm going to click on View 1 here, and I'm going to go in and maybe edit some of the dimensions. I can pick a component here and pick a specific line, and let me find one here, and actually edit the properties of it, and it'll show you all the details. I'm sorry, I'm in the wrong skeleton view to show you that. I'm still in the motion skeleton view. But my parts are all based off of this. They're all constrained to this. As I update this, it will update the parts that I'm basing this off of as well. So let's go in and let's open up our go into our Applications tab, open up our Mechanism extension, and we'll come in here. Notice you see a lot of my mechanism constraints. I'm going to come down to Analysis, and we'll look at the deck kinematics. If I edit the definition, you guys can see a lot of the things that are used. The time, the frame rate, the minimum interval, all of that stuff is defined right there. I believe there's already one recorded in here, so we will go ahead and play it. Let's see, I am I want to make sure that I've got this. Okay, Applications. I need to, I forgot to turn on my measures. I need to actually pick something to reference this to. So take one step back, and let's see. I need to expand my analysis mode, and I need to, let's close this here, run this guy. There we go. Now you can see it moving. So you can see it moved from the bottom to the, moved up ever so slightly. Again, I will, no, I don't want to overwrite it. In my playbacks, I've got that available in there now. I'm going to click my measures this time. Now, I'm sorry, I did miss that mouse click earlier. Like I said, there's quite a few mouse clicks in this demo. You can see it's got a value right there. I'm going to turn on my graph. If you notice here, if I go to my deck kinematics, and I click on my playback, it's going to, I need to bring this over here. Oops. Select the two results, pick the measures, close the measure results window. Now I'm going to come in and I'm going to click playback. Oh, sorry, there's my playback button. And I'm going to actually animate this, where when I click my play, it's going to go through the entire range of motion, and if I drag this over where you can see the deck moving ever so slowly. I'm going to speed it up so that way you guys can see a little bit faster. As it's moving up, it's measuring the distance from the ground distance, and from the deck to the ground, and then from the deck to the wheel. So as you can see, as my deck gets higher up off the ground, it gets slightly closer to the wheel. Well, this allows two different teams to come in and design the deck location based off of, the rough estimate of the wheel. They don't need all of the details of the wheel. They can get by with just the skeleton of the wheel. They can also get by without having to know a lot of the data that you would think you would need to know. With the bottom-up approach, I can come in here and specify things that allow me to quickly and easily go in and model something within my envelope that I'm allowed. And then I don't have to, someone else can come and do this, and then I can send someone else out to design the deck to fit within this part of the skeleton, so another team can go design the wheels that fit into the other part of the skeleton as well. Let's see, next. There are, if I close this guy out, and close this and close that as well, I'm going to come in and I'm going to close out of my deck kinematics, exit without saving. It's going to take me back to my skeleton. So now I've got, you can see I actually, in this case, have several other skeletons within this master skeleton. I'm going to open this specific skeleton here and edit this. In that case, it's just showing me, the dimension of the skeleton, the dimension of the cross-sectional area. I can select this part of the skeleton and maybe edit the definition of this, and you can see I've got a lot of surfaces and things that are defined, that I'm going to come back and mate things to. This allows me also to come in and change things around, put different seats in, using some of the things I briefly mentioned earlier. I can come in and mate things in and have the mechanism, work quickly and easily. Mechanism are modeled exactly correctly. If I come back up a couple levels to my overall master view, then I've got all of these components in here that are mated in, and you can see this is a pretty nice detailed model. This is something that really you wouldn't expect this to regenerate so quickly, because it is a graphics rep. It does, but I've got all these components in here that are going to work properly, and I don't have to worry about if I come in and change the shifter, change this deck lift pedal that's that you actually push down to raise and lower the deck, or this handle. Is that going to come in and is that going to break my assembly? If I suddenly change the distance from bolt A to bolt B from 4 inches to 4 1/4 inches, is that going to completely redefine the way my assembly works? Well, I don't have to worry about that, because my assembly is completely based off of that skeleton that I just showed you. So there's a couple other things that I'd like to show you. I don't know that I'm going to have the time to show you. Unfortunately, they are a little bit longer. Some of the variant designs where I can come in and select my mower deck and replace it out with a different mower deck. Unfortunately, to do that justice, or to change the seat out to a different seat, is going to take probably longer than we have left. If I did, there would be no time left for questions. So with that, I'm going to kind of toss it back over to you guys and let you pitch some questions to me and see if there's anything I can answer for you. So Rosalind, I guess can we unmute everybody now, or do we have any questions already on the list of questions?
I don't see any yet.
I'm not seeing any questions. All right, if you guys have any questions, type them in at this time, or there is a raise your hand button. If you want to verbally ask me a question, feel free to click that button, and we can talk person to person without the technology getting in the way. Well, again, I appreciate you guys coming out.
We do have a question.
Okay.
Let's see here.
Hopefully it's an easy one.
Let me get it to pull up. Okay, the question is, are there simplified reps at multiple levels in these assemblies?
I can't actually answer that. I'm not sure. I think that there are, but I'm not 100% certain. It looks like there may be some simplified reps within some of the sub-assemblies as well. But again, I didn't build this. I played around with it a little bit. I haven't dug that deep into it. So unfortunately, I can't answer that.
Yeah, we can get you some answers afterwards. It looks like we have other questions here. Does this functionality require the advanced assembly module?
Some of it does and some of it does not. There are some simplified rep things that are available now within just plain Creo Parametric. But some of the more advanced stuff I've showed you, and some of the more advanced stuff we'll show you again at a future date. Like the interchangeability of components. If I want to swap out a seat variant for another one, or a deck for a different one, that stuff does require the advanced assembly extension.
Okay, here's another one for you. Are there simplified? Do we ask this one? Are there simplified reps at multiple levels in these assemblies? I think we just answered that one.
Yeah, we answered that one a second ago.
Okay, and using the skeleton, how do you create the attachment points?
Well, there's a lot of ways. There's actually a training class that goes into this. I can't give you a really good answer quickly and easily, but there are multiple ways to create those attachment points. When you go in, you can, if you're creating a skeleton model in case of that piston that I showed you earlier, then I can specify just a point on a circle as being the rotation of that crankshaft. But there are multiple ways to specify those attachment points. I don't have to go in and create a mechanism or an actual. I don't have to go in and create my connecting rod first and come back in and create my skeleton from that. I can create my skeleton first, which is simply lines and circles, and then use that to create my mechanism connections. And if that doesn't answer your question, please feel free to ask again to clarify.
Okay, and there's also envelope versus simplified rep.
Well, I'm not exactly sure what you mean.
Or it was clarified further down. Use case for envelope versus simplified rep.
Well, actually, an envelope is one of the tools you can use within a simplified rep. So, you know, just like I can use a simplified rep to hide and unhide, you know, different components within an assembly. You know, maybe like I said earlier, if I'm showing an engine, I can use a simplified rep to hide all of the internal components and only show maybe the engine block and the heads and you know, the oil pan and all the stuff that goes on the front that I would be able to see from the external part of it. But all the internal stuff I can hide. But also another method of doing that, you know, within a specific assembly is I can create an envelope, which allows me to do it's very similar functionality. However, simplified reps are not limited to specifically just envelopes. Envelopes will take all of the components and create a new part, basically, that roughly approximates the location of all the old parts and, you know, hides the ones that you don't want to hide, and maybe facets, and, you know, then you get into shrink wrap and things like that, which it can get pretty complicated pretty quick. That's why they call it the advanced assembly extension, and unfortunately it does get pretty advanced.
Also, how easy is it to create an envelope of the assembly shown on the screen?
Well, I would say that the envelopes we've seen on the screen here probably are very complicated, but I would say, you know, something like this would take a long time to regenerate because there's so many complicated surfaces. But you know, something simpler like I showed earlier would be very, very easy, like the piston, or I'm sorry, that little camera. That's only you know, a couple hundred components at most. This has on the order of, you know, thousands and thousands of components in this lawnmower. So creating an envelope of this entire assembly would be pretty difficult, I think.
And also, Brad, are those graphics rep and geometry rep assembly files created automatically by Creo?
No, you actually have to go in. Well, that's actually, I'm not going to give you a direct answer, unfortunately, because I don't want to give you the wrong answer. Let me do a little bit of digging on that. And I thought I understood how that worked, and recently found out I didn't understand it as well as I thought I did. So let me get back to you on that specific question.
Okay, and here's another one for you. Are there any restrictions or limitations when users work with PDM link? For example, external references.
Well, that's external references. I mean, could you clarify exactly what you mean by external references? Maybe I'm just not grasping your terminology exactly the way that I think that I do. I guess, is that George?
That's correct.
I guess can we unmute George? Maybe he can talk at us.
He's unmuted if he has a microphone.
Hey George, are you there? If you can't talk to us, just go ahead and maybe clarify what you mean by external references.
And John just said external SimRep advantages.
Okay. Let me pull up I think I can see the questions box here. Okay, so
Okay.
John, I see you've asked a few questions here. Use case for envelope versus simplified rep. Again, an envelope would be a tool you would use within a simplified rep. However, you know, simplified rep is capable of doing a lot more than that. The Simplified Rep does give you the graphics view and the geometry view or representation as well. Advantages of an envelope over a Simplified Rep. I would personally use an envelope in kind of the smaller assemblies where I have a few components, where maybe a perfect example would be that camera, where I'm just concerned about the overall dimensions of the camera. I'm going to bolt it into something, or maybe I'm going to send this part out to be mated into another assembly, and I don't really care about what's inside of it. That's when I would use an envelope. Simplified Rep is going to be, something more where I'd be concerned about, like this larger assembly where I want to show all of the components that I can, but I don't want all of the data there with it. Let's see, external Simplified Rep advantages. Let's see, I'm sorry, another question popped up. I'm sorry, I can be a little easily distracted, see something shiny. So the advantages of an external Simplified Rep, again, would just be to speed up your processor, the regeneration times of an assembly. So since the parts collect their geometry, this is from George again, since the parts collect their geometry info from skeletons, the objects are dependent on other objects to open and regen. So the skeleton kind of is its own feature. It's created like another part within the assembly. It's more the other parts are kind of based off of the skeleton than the skeleton's based off of the parts that are there. I don't know if that answers your question or not. But as far as I know, I'm sure there are some restrictions when working in PDM Link. I'll talk to our PDM Link guy, and I'll get back to you on that, George, to make sure that I get a good answer for you. Unfortunately, I'm being so new to the company. I'm still new when it comes to the wind chill and PDM Link and all of the stuff on that side. One of my goals for the next quarter is to really immerse myself into the wind chill side of the business. My background comes more from the pro engineer side of things. Well, if I didn't answer your questions, please, by all means, let me go show the final slide on here. I've got my email address listed here. I've got, let me hide my taskbar here. That guy's popping up in the way. We've also got our YouTube page, youtube.com/user/customer-driven-tech. Will take you to all of our past webinars, including the ones Ben and Suk have done recently. And as we started recording those a few months ago, and so we've got quite the display, quite the assortment of things there. If I didn't answer your question correctly, I know there's a couple of them I'm going to respond back to afterwards, make sure that I give you good information and not just come up with something off the cuff. But if there's something else you want us to talk about, or if you come up with something later when you're laying in bed at night tonight and you really want to know some more, feel free to email me or Rosalinda. Our email addresses are there. Note, because of the Barry-Wehmiller acquisition, our email addresses are going to change soon, but they will still continue to work for the near future at least. So when we get all that lined out, we will be updating all this information as well. And with that, I thank you for your time. I appreciate you guys letting me cut this a little shorter than usual. Since I am teaching class, I'm going to have to run down and grab a sandwich. I'm getting pretty hungry, unfortunately. So, George, no problem. I realize I see here you said microphone's not working. We will catch up with you later, make sure we get all of your questions answered. We do appreciate all of your time coming out and watching the webinars.
I'll be sending out.
If there's anything you guys want to see, yeah, go ahead, Rosalinda.
I'll be sending out an email with the link to the webinar replay once I have it up and running. Great. And we do look for things to present. We do have the next month and a half or so planned, but if there's something you do want to see, and especially if we get a lot of people saying they want to see a specific function, like can't remember, there's one recently that we had 4 or 5 customers that all wanted to see, so we pushed it up in the order and changed the order around a little bit. But we do want to make sure that we gear these towards you guys and we give you what you're looking for. So if there's something you want to see, then by all means let us know, and we will make sure and show it to you. And also one more thing, Brad, for those of you that were trying to attend last week's Creo Piping and Cabling Extension webinar,
that was rescheduled at the last minute. We are having that set for the same time tomorrow. For those of you that couldn't attend, actually, I think that'll do it.
All right. Well, again, thank you for your time. I appreciate you you coming out and watching us do our little song and dance. Thank you very much.